Hey guys, this is Ganesh. Today let's discuss the topic CNN, Convolutional Neural Network. First, let's see what is CNN. In neural network, convolutional neural network is mainly used to recognize images or image classification or to detect objects or even face recognition. As you can see in the image, convolutional neural network is made up of numerous structure blocks like convolutional layer, pooling layer, and fully connected layers. Now, first let's discuss about convolution layer. Convolution layer is the first layer to extract features from an input image. Convolution preserves the relationship between pixels while learning image features using small squares of input data. It's a mathematical operation that takes two inputs such as image matrix and a filter. As you can see here, there's a 5x5 image and a 3x3 filter. As the filter slides over the image, we can extract the features of the image. Now, let's see what is striding and padding. Striding is a way by which we can control the movement of filter. When the stride is 1, then we can move the filter to 1 pixel at a time. When the stride is 2, then we can move the filter to 2 pixels at a time, and so on. And padding is a way by which we can use the corners and edges of our image efficiently. Padding is a process of adding layer of zeros to our input image. As you can see here, the input image is padded with zeros. This is called padding. Now, let's discuss an example of striding and padding. As you can see here, the input image is padded by one layer of zeros, and the 3x3 filter is slided over the image by leaving a pixel in between, which means here striding is 1. Pooling. Pooling is a way to reduce the number of parameters when the images are too large. There are 3 types of pooling: max pooling, average pooling, sum pooling. Max pooling returns the maximum value from the portion of the image covered by the kernel. Average pooling returns the average of all values, while sum pooling returns the sum of all values. Now, let's discuss about fully connected layer. Fully connected layer is simply a feed-forward neural network. Fully connected layers are the last few layers in the network. The input to the fully connected layer is the output from final pooling layer or convolution layer, which is flattened and then fed into the fully connected layer. Then it uses the final probabilities of each label to predict the output. As you can see here, the output from pooling layer is flattened and fed to the fully connected layer. Fully connected layer takes them as input and outputs Y. Applications of CNN are recognition tasks and object detection. Did you ever wonder how Facebook suggests the correct people to tag on their photos, or how facial recognition works on your smartphones? The reason behind them is CNN. It can also detect the objects from a far distance, like it can count the number of cars or trucks on a highway. Not only this, but there are so many applications of CNN. Now let's see for which application the deep learning technique doesn't fit in this current world. In live speech recognition, BRNN, bidirectional recurrent neural network, doesn't work because BRNN need the entire text to process. So, in case of a live speech recognition, until the speaker doesn't stop, BRNN model doesn't give the output. So in this current world, for a live speech recognition task, BRNN doesn't work. Thanks for watching.